Practice B for section 2.6, we're going to do these first two fill-in-the-blank proofs together. So in number 1, they tell you the distance from H to I is 9. So I'm going to just kind of mark this on the diagram to help me. Also, I to J is 9. They're also telling you that segment IJ is congruent to segment JH. Well, if this is 9 and it's congruent to this, how long would this be? We know it's going to be 9 also. Do you think you could prove then that segment HI is congruent to segment JH? Yeah, it seems like a pretty easy, simple thing to do once you believe it. Okay, so make sure you believe it first, fill in that information or use some numbers if they don't give you numbers. That way you're confident that you know that this is true. Now actually filling this in, filling all the steps of geometry, and that's a different challenge, but in time you will develop these skills the more you see them. Okay, so how do we know H to I is 9? That's given. How do we know that I to J is 9? That's given also. You didn't have to separate these two steps, but they chose to. You could put them both on the same line. Sometimes though, when you separate them, it's easier to see what they're giving you to use. If you jam a whole bunch of things on one line, sometimes it gets confusing and hard to see. How do we know H to I equals I to J? It doesn't have anything to do with the diagram or the given statement. If you look at the two things that you just stated, you have two different things that equal the same thing. So what do you know about those two different things? They're the same as each other. That's your transitive property of equality. Now, where do you go next? Well, you could go a lot of different ways, but they want you to use the definition of congruent segments next. So if you have equal length segments, what does that mean about them? That means they're congruent. So that's what you need to say. Segment HI is congruent to segment IJ. Now notice what they say in statement 5. They're going to now say that segment IJ is congruent to segment JH. And this might seem really, really odd. Where did we get this from? Where did it come from? It didn't come from any of the previous steps or the picture. If you look up here, that's actually the third thing that was given. So we don't have to state all of the given on one line. You can kind of split it up and state it when you need it. So for example, the reason they did that was it's going to make sense now to look at this line and this line to make this statement. Notice how you have two congruent segments, and then you also have two other congruent statements, and this one thing is congruent to both of these. So when you have something that's congruent to two other things, those two other things are actually congruent to each other. That's your transitive property. Now look how I use property of equality up here. I'm going to use the property of congruence here. Here's number 2. Angle 3 and angle 2 are complementary angles. Alright, so I'm just going to make up some numbers here because I want to make sure that I believe that this is true. I know that complementary means they add to 90. So I'm just making up some numbers. Let's say that angle 3 is 60 degrees. That would leave 30 degrees for angle 2. Again, I need them to add up to 90. I'm allowed to use that. They're also telling you that angle 1 plus angle 2, whatever their measures are, have to equal 90. So here's angle 1 and here's angle 2. We know they have to add up to 90. That's a different way of saying complementary. So if angle 2 is 30, what's angle 1? It's going to be 60. Look at angle 1 and angle 3. What do you notice about them? They're the same measure or congruent angles. So you should believe that this is true. Now, I just made these numbers up. Okay, we want to show that this works in every single case. We want to show that it works if this is 59, and so on and so forth, or 58, or 50. You get the idea. Okay, so angle 3 and angle 2 are complementary angles. That's given. Measure of angle 1 plus measure of angle 2 equals 90. That's also given to you. Measure of angle 3 plus measure of angle 2 equals 90. How do you know that? Well, you could look at the picture, you could look at the given, you could look at some of the things you already stated. Notice how we said that angle 3 and angle 2 are complementary. What does it mean to be complementary? It means they add up to 90. So what you're actually using there is the definition of complementary. Now, if I was writing this out on my own, I would put this statement right after this one. But you can squeeze something else in there if you wanted to. It's just easier to follow if you put those things next to each other, I think. Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus a measure of angle 2. How do we know that? Well, look at statement 2 and statement 3. Notice how they both end up equaling 90. Well, if you have two things that equal the same thing, then those two things are the same as each other. That's your transitive property. Now, when you look at this equation, this is going to follow directly from there. It's not in the picture, it's not in the given, this follows from this. You have a measure of angle 1 and a measure of angle 3 on the left side and the right side of that equation. Notice how you also have a measure of angle 2 on both sides. Well, if you have something on both sides, if you subtract it from one side, you subtract from the other, it disappears. They cancel out. That's your subtraction property of equality. And now if you have two equal measures, don't you have congruent angles? That's the definition of congruence.